Yes, thank you. I will take over. Thank you, madam. Yes. Yes, so my dear staff and students, at the outset, I thank the management of SRM University and Dr. Shanmugasundari for having invited me to address these altitudes. I think the third time I am addressing altitudes. And apart from certain other visits to SRM University, I am happy to be again with you. Let me share my screen and then start talking to you. I would like the host has to enable screen sharing for me. Shanmugasundari madam, the screen sharing may please be enabled.
Sir,
I want
yes,
to
sir,
share
yes,
my
sir,
screen.
I am doing. Yes, sir.
Yes.
Is it okay, sir?
I will try now. Yes.
Okay.
I am sharing my whole screen. Yeah. Yes. As I was introduced, I am associated with the Sri Sathya Sai University for Human Excellence as a Registrar Evaluation and Dean, Research and Innovation. I am happy to be part of this organization which runs over 27 schools in Karnataka, 5 child care hospitals and PU colleges and one university absolutely free of cost. I am proud to be part of such an organization. This is how I can be reached in case you want to reach me. So I have chosen a topic. Give back to society with mathematics.
Yeah.
See, all of us have taken birth on this earth. And we derive so many things from the society. So if I am able to talk to you on web, online, there are so many other fellows involved in this. My assistant puts the lights on. Somebody keeps the internet on. Okay, somebody works overnight to keep the internet on. All your teachers are assembled there. Somebody is arranging. When you are reaching your college by bus, the driver drives it. If you have a neatly washed and ironed shirt, there is somebody to help you. The hair cutter helps you, makeup man helps you. Society, you get so many help from so many societies. You are going through a road, suddenly you find the road very good the next day. Somebody has laid down the road for you overnight. Somebody cleans your drainage. See, we get so much from society. So, we should also give back. Yes. I would request all the others to mute. No other conversations, please. All others, please mute your mic. I request all others to mute the mic. Some other conversations are going on. Yes. So we have to give back to society. We do social service. So many things we can give back to society. See, doctors are there. They serve the society. They are available round the clock during this pandemic. You have seen their contribution. Your teachers are there. They teach us. Okay, they teach back to the society. They are not teaching their own children. They are teaching other children. Lawyers are there. So many people. They contribute to the society. So what do we do? So since we have assembled in the name of mathematics, we are here in the name of mathematics. What mathematics can do for the society? Your dean was referring to mathematics as the queen of all sciences. Why is it so called? Was it so in the previous days, or it continues to be so? The mathematics, unlike the previous years, maybe unlike previous few decades, it has grown enormously, getting into a very possible field, and not only science. Mathematics have gone into arts, science, technology, dance, music, everywhere. I will show you some samples. There are books, music and mathematics, okay, for example. There is a monograph on music and mathematics. Anything, mathematics has gone into anything and everything. Computers. If you go to the ATM machine, mathematics is sitting there. If you go to a bank to put money into that, mathematics is sitting there. If you have a fussy logic supported washing machine, mathematics is there. You don't know. I will tell you, I can somehow tell how this happens. So it is there everywhere. And as a student of mathematics, see, you might be having one or the other papers of mathematics. Science students are there, humanities students are there, I understand. Somewhere you will get to know about mathematics. Even BCom students will have some sort of business mathematics. Your dean is an economist. There are mathematical economics is there. So what do I intend to do in this? In maybe next till 11 o'clock or something, maybe half an hour I will consume. Half an hour at the best. I will not get deep into anything. Okay? Since children are there, students are there. Some may be wondering what sort of applications this mathematics has. That is, live applications. In what way mathematics helps the society? Mathematics is numbers. What is there? What the numbers have to do with the society? It is numbers, and finally some calculus, this, that, etc. And when you go to practical applications, this mathematical, Microsoft Excel is sitting there to do things for you. There are so many mathematics packages. Mathematics contributes to the society through mathematical modeling, through a term. So I will introduce certain terms to you. Maybe you are UG students or PG students, engineering students, I am not sure. I will throw certain terminologies to you, introduce you to certain terminologies. If you are interested, you can get into them. Maybe I will share this PPT also. Okay. And I share my number also. In case you want to know more about it, you can get in touch with me through WhatsApp. Right. This is the first slide of any of my talks. Have the mindset of a child. That's just observe. Just observe. Not with the mindset that I don't like mathematics. Not with the mindset that I like mathematics. Not with the mindset that mera kya, mujhe kya. Okay. I have a disclaimer to make. This concept of mathematical modeling. Again, I request all other mics to be muted. Please mute all other mics. Some conversation is going on in between the members. That's disturbing me. Hardly 100 members are there. Please mute all your mics. That's my request. I don't understand. Please ensure that the mics are muted. This
Yes, sir. Muted, sir.
muted, some conversation I keep on hearing. Some noises. Yes, thank you. I am only responsible for the flow. Nothing is invented by me. I have collected things from other books and showing to you. The mathematics is the modeling language for real world problems. For real world problems, it's a language with which mathematical modeling is the language with which mathematics communicates to the world. Mathematical modeling is the tool with which mathematics is useful to the society. I will quickly go through this. There are various types of models. Iconic model, physical model. That is, physical models are something like your Taj Mahal models. Taj Mahal models. Wherein you have a small model of Taj Mahal to understand what is Taj Mahal. So dynamic model, normative model, so many models are there. Analytical model, simulation model, and one of them is mathematical modeling. You model through mathematics. You must have seen the dolls in the garment stores. They will be wearing different shirts and saris every day. They are models. And you are seeing models who introduce a product. You are seeing a model who introduce a product. So this mathematical modeling, what does it do essentially? It helps you to understand the situation as a mathematical concept. Then mathematical tools are there, they solve the concept, and the mathematics will give back to you a result which you can interpret in the terms of real life. I will give some samples. Okay? Don't worry if you do not understand them deeply, but to get to know the terms, that will help you sometime in your life while doing projects or while giving a talk. You will come to know what are all the concepts of mathematical modeling. So mathematical modeling is a schematic description of a system, right? Engineering and science students depend heavily on mathematical modeling, whether you are aware of it or not. When everything is done on computer, but you must understand the underlying mathematics, what the computers are doing. This is how a model works. Just to have a look at it. Okay. You have a system, model it with variables, parameters, then model predictions, test it, then accepted predictions. This is a visual flow of mathematical modeling. Now I will get into the topic, mathematical modeling of real world problems. How do we seek the help of mathematics in solving the problems of the society, in helping the society? How a mathematician can be useful to the society? Right. I will start with a very simple example. I will start with a very simple example. As simple as that. That what you do in schools. The length and width of a rectangle together measure 130 yards. The difference is 8 yards. The difference is 8 yards. What is the 1 minute? What is the area of the rectangle? It's a very simple problem. There are two ways to solve this problem. One is put the value as x, length of the rectangle. Then width of the rectangle is x plus 8. Together they measure 130. So x plus 8 is 130. 2x plus is 130. X is 61. So you know the length and breadth, you find the area 4209. Another approach is to represent the equations as x and y. Let x equal to the length of the rectangle and y equal to the width of the rectangle. Since the sum and width is 130, x plus y is 130, x plus y is 130, x minus y is 8. So here also I get x equal to 122, x equal to 122, y is something, and I get the product as 4209. This simple converting the equation problem into equations. So what's the problem? To find the area. You are modeling it with x and y, solving with the mathematical methods for x and y, then get back to the problem. What's the problem? What is the area of the rectangle? So from the problem to mathematics, and in mathematics you solve the problem and come back to the original solution. Right. This is a very simple example. There are further examples of differential equations. When a body falls from a tower, what is the differential equation? Y double dash equal to G. And when you glide through a parachute, what is the equation? So the movement of the parachute can be put as an equation mg dash equal to mg minus bv square, and so on. These kind of problems are represented using differential equation. So what they do, a mechanical problem or electrical problem is converted into a differential equation, and the mathematics will help you to solve the differential equation. The solution of the differential equation will give you a clear picture on the real life problem. So this you must have seen. So differential equation is a type of mathematical modeling. The other circuits, they are represented by differential equation. Okay, you see various examples. Then that's a concept of algebraic modeling. You know there are various subjects in mathematics: differential equation, algebra, matrices, graph theory, calculus. I will highlight some of them. So I just told you differential equation is a term of mathematical modeling. Algebraic modeling, we will look into it. Just to have a look at this. This problem in fast printers for computers. The issue is, you must have seen in our computers, when paper is out, the printer won't print. It detects, that's a sensor, it detects that there is no paper in the printer, and the print won't go on. Print nahi chalega. Print will not go on. How does the printer detects the absence of a paper? This can be modeled. Just to have a look at it, it's something like this. The paper strip is there. Paper strip is taken through cylinders. And when the paper strip is there, it blocks the light from the lamp to photocell. So when paper is not there, the photocell will catch the light of the lamp, and it will give a warning lamp and stop the motor from working. This is the basic diagram. What do we do with mathematics? We do some such calculations. So A1 is 1, A1 0, A2 1, A2 0. And we get some functions which are 1 when motor operates, which are 0 when motor is switched off. And the values are summarized in a table like this. And from the table, algebraic expression like x1, x2, x3 dash, this is formed. This algebraic expression, Boolean expression, is converted into a circuit. You must have seen the circuit and the gate. So this is a gate circuit, electronic circuit. So this electronic circuit sits in the printer like this, and it detects the absence of a paper. This sort of mathematics comes from a concept called discrete mathematics. There is a concept called discrete mathematics. What is discrete? Discrete is not continuous. That is, what are all the mathematics that are needed for computer science are put together in a paper called Discrete Mathematics. So, if you study Discrete Mathematics, you will know how to, if you study Discrete Mathematics, you will know how to design electronic circuits, how to minimize electronic circuits. You will understand how a ATM machine works. You will understand, you go to a railway station, you can measure your weight, how that weighing machine works, how the platform ticket vending machine works. And you are getting a lot of, when you go to a vending machine, you will get Coca-Cola, you will get coffee, right? You will get so many things. Put a 10 rupee coin, you will get a cup of Coca-Cola. You will get a cup of soda. How do those machines works? Such concepts can be studied with a concept in mathematics called theory of computation or automata theory. If you study that, you will come to know about all these finite state machines, that is ATM machine, vending machine, weighing machine kind of things. How do they work? There is strong mathematics behind it. How do they work? You will come to know. If you want to study this, the suitable papers are automata theory and this. So, if you study automata theory well, you will be able to help in designing the ATM machine and other machines. They are very much useful to the society, right? So, you will understand how do they work. You will be able to help the company to develop a better ATM machine. Okay, you are seeing ATM machines are improving day by day. It is not only giving money, you are able to do so many things through ATM machine, right? So, such a concept is called discrete mathematics put together, right? Then, I will get back to a very familiar mathematical structure which is known to you called matrices. So, matrices are also helpful in modeling. How? Matrices, let me give a scientific computing libraries have seats in matrix calculus. The control theory involves spectral analysis of matrices. DFT, the DFT is involved in communication, discrete Fourier transform. The electronic people or electronic engineers will study most of this DFT. Statistics is sitting there, that is based on again matrices. These are some more examples where matrix is modeled. That is, a real life situation, I will take again a very simple real life situation which are modeled as matrices. Students may just look at this, just to hear the terms. Matrices can be modeled, graphs can be modeled, statistics can be modeling, like that. Just listen, so that when really you need them, you will be able to get hold of the book and study them. So, I have a very small problem. Let's say you find out the final, yes. Let us say we want to find out the final grades of 3 girls, and we know their averages for test, project, homework and quizzes. Okay. You know that the exams are conducted for various marks, 100 marks, 50 marks, 30 marks, and only the percentage is taken. So, even if you conduct it for 50 marks, they may take it for only 25 marks. 50% may be considered. So, the projects, 40% of the grade are for tests, 50% for projects, 25% for homework and quizzes, 20%. That makes the 100% marks. Now, I have the marks that are taken for 100. But even though the test is conducted for 100, only 40% of the test is taken into consideration. So, these are the marks obtained by Selvi, Margaret, Fatima on test, project, homework, quizzes. So, this is naturally a matrix. And here, I write down the weightage of test, project, homework matrices. Weightage of test is 0.4, project 0.15, like that. Now, you can just put this as a matrix product. So, this matrix of marks and the matrix of weightages when multiplied together give you 90, 77, 87. That is the actual grade for this Selvi, Margaret and Fatima. So you are seeing a very simple example, the mark problem that is converted into a matrix and that is solved through mathematical the matrix multiplication, and the resultant matrix 90, 77, 87 that gives you the grades for the original problem. So in mathematical modeling, what do? You get the problem in real life. Then if you can organize it as a mathematical entity, as a matrix or a differential equation or a statistical entity or probability, anything, then solve it through mathematical methods and get back to you. Suppose you many of you might have gone to blood testing. Okay, you go for blood testing. What do? The blood test. Abba. Please, all of you, mute yourself. See, you go to a blood test. What do? You go to the doctor, lab. They take the real blood from you, right? You know only blood. Blood is there in your body. They are taking your blood. Good. Then what do they do? You don't know. They take your blood. For them, blood is a sample now. Blood is a sample. That sample they will put in one of their machines. Hope I am audible.
Yes, sir, you are audible.
Yes. Some it says unstable. Right. They go to their lab. They put your blood in various machines. Okay. And the machines give some calculation, some numbers. They will mix your blood with something, some chemistry they are doing, some biology they are doing. Whatever they do, they finally give the result in a paper. In your blood, urea is this much, glucose is this much, there is some infection. All that they give in a printout in a way you understand. So that is medical modeling. They take your blood and give you back the result, and in between they do some analysis in the lab. Mathematics is like that. A real life problem will be there and that will be given to a mathematician. Mathematician will put it in appropriate form and solve it with appropriate mathematical methods and give you back the result. This is how mathematics is useful to the society. One more graphical model, mathematical model is called graph theory. What's a graph, for example? Graph is like this, dots and lines, like column. So dots and lines. These are graphs. That's all. Nothing more you need to know now. Some examples of graph theory. Graphs. This is a flow chart. Flow chart is a type of graph. Organization chart is a type of graph, like that. Now, one important application of graph theory, I will let you know. For example, if I want to color the states of India, if I want to color the states of India in such a way that the adjacent states have different color. The Tamil Nadu and Kerala should have different color. If Tamil Nadu has red, Kerala has to be painted with green, right? So, adjacent states should have different colors. There are many states in India. How many colors do you need? Suppose there are 29 states in India. How do you need all those colors? No. Mathematics tells you 4 colors are enough to color the graph. With 4 colors, for example, if you color Tamil Nadu with red, you can color Maharashtra with red. No problem. So, this graph theory is there. Graph theory tells you that India map, any map can be colored with only 4 colors. 4 colors are enough. This is called a coloring problem. What are the other applications of coloring problem? I will give you some small example. Your timetable problem is there in colleges. Examination timetable problem. Okay. So, some students will be taking multiple exams, right? It happens. They may have regulars or year papers or electives. They will take multiple, so many hundreds of students are there, so many papers are there. Suppose there are 100 papers, do you need 100 dates to conduct the examination? No. You conduct the examination within 15 days. How do you manage? When the exams are not overlapping, you can schedule them on the same day, same time. Okay. If calculus and differential equation are taken by different groups, calculus and differential equation can be conducted on the same day. So in arranging, minimizing the timetable, graph theory coloring problem will help you. This is the timetable issue. When there is star, it means that they cannot be scheduled on the same date. This can be converted into a matrix, graph, and it can be subjected to the graph coloring problem. And it says chromatic number is 4, then all these 7 exams can be conducted on 4 days. So graph theory helps you to solve the timetable problem. It's the biggest headache in any university. Graph theory can be applied. It can be done as a small UG project or PG project. Take any timetable, classroom timetable, exam timetable. Then one more example I will give. This timetable scheduling. Then one more, see, there is a warehouse, there is a big room. I have to store 5 chemicals there. Certain chemicals cannot be put together, they will react. So, how many areas do I need? How many partitions do I have to make there? You have the table, these are the chemicals, and wherever star comes, A and B cannot be put together, A and C cannot be put together, A and E can be put together. With all these combinations, how many areas I need? Do I need 5 areas? Can I minimize it? Let me see. I will convert it into a matrix. How do you do that? It will take another lecture on graph theory. So somehow I am converting this into a graph. I am applying graph coloring problem there. I am getting one answer. It gives 4. That means these 5 chemicals can be stored in 4 areas. 1 area is saved. So graph theory applications are like this. Graph theory is applied in the game of Sudoku also. In solving the Sudoku game also, it is applied. There is a paper, I am quoting the paper, graph theory and its real-time application. So that's all with graph theory. So I have maybe another 15 minutes, I will conclude. That's all with graph theory. So I told you about differential equation, graph theory, algebra, discrete mathematics, matrices. I will touch upon one important area where mathematics is highly relevant to business, optimization. So I will talk quickly about mathematical optimization. This is not usually taught in undergraduates, but better to know about this. This is also called a concept called operations research or mathematical management science or operations research. Right. So this is what they do in not this experiment. They will take variable, constant, objective function, mix everything and get to know the optimized result. I will just tell what is an optimization problem. Optimization problem is nothing. It's something like, right, I have 500 rupees in my hand. I think nowadays you will have to carry 500 rupees to go to a vegetable market. I have 500 rupees in my hand and I have a bag which can hold some 8 kilos. 8 kilos can be held in that bag. I go to the market. I have so many options there, so many vegetables, so many markets, so many vegetables, so many rates, so much thing is there. So I have to purchase for a week. So what I will try to do? I will try to get to more vegetables for less money. Suppose carrot is very costly, I will go for a brinjal, something like that. So I have to optimize the money in my hand. And suddenly I cannot purchase 10 kilo because I have a bag which can carry only 8 kilo. So the bag is a constraint for me. 8 kilo is a constraint for me. 500 rupees I have in hand is a constraint for me. Lot of opportunities are there. Lot of vegetables are there. So what do I purchase there? with the minimum money. So even if I spend 400 rupees, I must get a kg of vegetables. Okay. That is what? This is a optimization problem, life optimization problem. So these optimization problems, concept is called operation research, and management science books are there to help you. This operation research discipline explicitly devoted to decision making. Your dean was telling about it. I was just thinking about it. This is a kind of decision making where operation research helps you. There are a variety of problems that can be solved and modeled with operation research. I will come back to it in case I have time. Some illustrative linear programming problems I will give. In operation research, there are various chapters like linear programming, non-linear programming, dynamic programming, transportation problem, assignment problem, allocation problem. So many are there. They are linear, called linear programming because only linear variables will be involved there. So like I am not going to tell you how to make these dosas, but I will just show you how many varieties of dosas are there. How many varieties of optimization problems are there. That is of attraction to business students, economic students, anybody. Just have a look at them for another 10 minutes. This kind of problem where a cabinet maker wants to make cabinets of model 1 and model 2, and he has limited woods, he has limited labor time, okay, and he wants to maximize the profit. How many cabinets should he make with available wood and available labor? Okay, this problem can be modeled mathematically like this, and it can be thrown to the Excel sheet for modeling, and it gives some solution that 4 units of model 1 and 0 units of model 2. It can be expanded like to many models. It has 5 models, many wood, rose wood, plywood, redwood, so many combinations. With that I want to make 5 models. So how many number of which model I make? This can be, when you put it in Excel, it's a mathematical model, it's a mathematical equation represented by Excel, Microsoft Excel. So it can be shown as a mathematical model and gives you answers. This problem I will take up. A bouquet problem, for example. See, you know how bouquets are made with the combination of various flowers. Okay. So I have this problem, this bouquet person's problem. You have to help him, right? The bouquet person has a problem. What is it? He has a rose, jasmine, gilliflower, Bengal rose, Bankinsia rose, all roses he is having. He has limited numbers of those flowers, and each flower costs something. So with this, he has to make varieties of bouquet. So nobody wants a single variety of bouquet, right? When you go to bouquet shop, you will look for varieties of bouquet. So he has to make varieties of bouquet. Varieties of bouquet means various combination of these flowers. One posy variety, rosy variety, like that, so many varieties. Each variety has selling price. So that variety he has to offer from lower price to higher price. So how much bouquet should he make to maximize his profit? This is his problem, right? This is a real problem. So he comes to a mathematician like you, and you model it mathematically like this and gives him the solution. You tell, right, how many bouquets you make. You make 166 first type of bouquet, 50 fourth type of bouquet, second and third type you don't make, that won't give you profit. So this is a bouquet problem. One more type of problem, that you go to sweet stall. What do? You go there, sometimes you get 1 kg laddu, 1 kg Mysore pak. Most of the time we will ask for assorted sweets, right? Don't we ask? Give me assorted sweets for 1 kg. Right? But you must have watched there. He will put more of cheaper sweets he will put one piece of badam cake, badam halwa. He will put one piece of cashew nut halwa and more pieces of Mysore pak, something like that, right? So he has to decide the combination so that it looks good to you, it comes to 1 kg, you are happy, and he is maximizing his profit. Suppose you want more of badam halwa in assorted thing, he won't give, right? So how to, this is a manufacturer's problem, a ordinary sweet wala's problem. There are many mixtures, for example, I am going for a mixture. There are many mixtures. You must have seen Madras mixture, Bombay mixture. So it will have same variety. They will have groundnuts, they will have chips, they will have this chips, that chips. Okay. So various combinations of these. Some will have more cornflakes, some will have more karashev, something like that. So there are varieties of mixtures. So which variety of mixture do I make, how many kg, so that my selling profit is more, customers are happy. So such a problem can be attacked with mathematics. Then advertisement problem. See, it is very simple. Even your university or you are making a shop, I want to advertise. There are so many means to advertise through TV, through radio. You can issue bit notices, right? You can put in a newspaper. Even if you want to put in a newspaper, there are so many varieties of newspaper. On Sunday there is a rate, Monday there is a rate. Even if you advertise on TV, during a serial there is a rate, during a cinema there is a rate. So my problem is I want to advertise my product, my college or my tuition center, or I want to raise donation, anything. I want to do so many things, and I want to reach many people at minimum cost. At average cost, I want to reach many people so that my product is sold. This is a media advertising problem. This is for everybody. So mathematics helps you to solve this problem through operations research. Then certain other problems are there. The doctor scheduling problem is there. There is a very big hospital. Hundreds of doctors are working. There are so many shifts. So, see, the shifts will be overlapping. Okay? So, how to have correct number of doctors so that the hospital runs smoothly, or how to have the correct number of salesmen so that a big supermarket runs smoothly. You cannot have less salesmen, you cannot have more salesmen. You should have the optimal number of salesmen to maximize profit, to serve the customers, right? To minimize expenses for the fellow. So this kind of business problems can be handled, right? Then certain other problem I will touch. This shortest path problem. This is a very common problem. That is, suppose a fire engine is there, it wants to travel from the fire station to the place where it is needed. So there are so many routes. Which route is the shortest? So this is the shortest path problem. This can be solved through the division of mathematics called operation research. Through packages also it can be done. It's a very, very relevant social problem, right? Then transportation problems are there. Like, what's the transportation problem? There will be various factories. Okay, if cycles are there, it will be manufactured in various factories. It has to be sent to various dealers. So from which factory to send to which dealer, how many cycles? So the transportation cost is minimum. I want to send all my cycles to all the dealers. They have their requirements. I have to meet the requirements, and I have to minimize the transportation cost. So how to minimize the transportation cost? In transporting anything, everything, rice bags you can transport books. So transportation problems can be there. Then decision problems can be there. For example, I will be very, very brief on this. Suppose a company is there, it makes 3 products: oil face wash, dry face wash, silky face wash, and which face wash he must produce so that to maximize his profit. Right. So these are called the optimization problems. Okay, I will cut this short. I will conclude with a branch called statistics. So I told you about operation research, which solves optimization problems of life. So if you have a problem to be optimized, that is with the minimum expense, maximum profit, you can approach operation research expert and he will solve the problem for you. Finally, I will touch upon a branch of mathematics called statistics. So you will have certain these results. 86.4% of the people believe that if you put anything on the PowerPoint slide, they will believe it. Then why I clean my room? This is a survey made. What are the world's safest countries? Okay. This is done through statistics. Some data you collect, you analyze them and decide which country is the safest. Then mean salaries of people. Do you struggle more with the time management? Yes or no? You can make a survey and conclude that people have more trouble in time management. And these are famous excuses of students for being late. How do I get all this? Sorry, I am late, I overslept, my alarm didn't go off. So a teacher wants to make a study. What are all the top 10 excuses given by students for arriving late? Or what are the top 10 excuses given by employee for arriving late? Okay. This study I make. Why don't people do exercise? What are all the excuses they have for not doing exercise? Some study I want to make. Okay. The percentage of cancer deaths by this one. Like that I do. Such things can be done by a branch called mathematics. Mathematics collects data and there are methods in statistics to analyze the data and there are methods to represent like this pie diagram or something like that so that you understand you must have seen all these diagrams in your life. So that the data is represented and the solution is given. One more last point on, you have a look at it. I will conclude with a topic called machine learning. You are instantly able to recognize which animal is this, right? First one is tiger, then horse. You are able to say. How does your mind say this? Mind already knows how a tiger looks like. If you make a machine, if you will be able to make a machine to understand this, how do I recognize a tiger's tail? Can a machine recognize this? Can a computer recognize this? Can a machine learn the way a human learns things? I have learned this, right? I have seen various pictures of tiger, various pictures of horse. So just by looking at the tail of the horse, I will be able to say it's a tail of the horse. Okay. So can machine learn in the same way? This concept is called machine learning. That is a major shift in mathematics to computer science. Okay. So machine learning is a concept which helps you to teach machines to learn the same way humans learn. Right. So I think I have touched areas wherein mathematical modeling can help to solve the problems of the society. Okay, I will stop presenting now. So see, this is how a mathematician can give back to the society. This is how a mathematician can be of help to the society. This is how I can be helpful to the society through mathematics, right? So I think I will conclude here. Namaste. I know that I have given a very quick bird's eye view of all the concepts. Many of them might be new to you, but this is told you to understand that mathematics has a wide variety of applications in real world problems. Okay? In the problems of day-to-day problems of the society, mathematics can be applied. Okay, namaste. I conclude by now. Thank you.
Thank you, sir.
Inspiration.
Thank you so much. Our students are inspired by your speech, sir. They definitely understand the applications of mathematics in real life in a better way. Thank you, sir. Thank you so much.
Well, thank you.
Darshan?
Inspiration can come us at any time. The thought-provoking words of our distinguished chief guest, Dr. T. Venugopal, sir, prove it to be true. I thank you, sir, for motivating and enlightening us with this knowledge in your speech. Thank you, sir.
Ma'am, sound is clear. You are not audible.
Yes,
Sorry, sir. 1 second.
yes, some connectivity issue.
Sorry, sir.
Yes, yes.
Good morning to all. It's a great honor and privilege to propose a vote of thanks on this memorable occasion. First and foremost, I thank our special guest, Dr. T. Venugopal, Dean Research and Innovation, Registrar, Sri Sathya Sai University for Human Excellence, who despite his busy schedule has found time to